Okay, so today we're going to continue on solving trig equations, but this time we're going to have to do a little bit more work. We're going to have to manipulate the equations, sometimes using the properties, in order to get this job done. So some of our strategies that we've got are sometimes we need to get the argument to match. In this case, we've got theta and theta, so the arguments are the same, but if you notice, we've got sine and we've got cosine. So we either need to get the functions themselves to match, or at least so that we can have them work together, where we can somehow factor or something like that. So, and then eventually we'll isolate our trig functions to solve, just like we normally have. So in this case, we need to get our trig functions to match up. If we move this side to the other side, we won't be able to factor because we've got sine, we've got cosine. But we do have a nice property that can change sines and cosines into each other, especially when we've got something squared. So we've got sine squared theta. Let's use the Pythagorean property to rewrite sine squared theta as 1 minus cosine squared theta. So that's our first step. So we keep everything else the same, bring down the 2, just replace the sine squared theta. I also distributed my 3 over here to save a little bit of time. So now that we've got cosine and cosine, we've got theta and theta, now we just need to work on isolating our trig function. Because we've got a squared and a not squared, we need to get everything on one side and 0 on the other so that we'll be able to factor to solve. So go ahead and work through this. I'll show the steps, so if you need to pause, go for it. So I distributed, then I am rearranging to get everything on one side and 0 on the other. Now we've got a quadratic expression here with our cosines. Remember, if it helps to factor this one, think of it in terms of a variable like x. And either way, go ahead and factor. Okay, so once you have factored, then you can use the zero product property to set each of these factors equal to 0, and we'll continue solving. So we can see cosine theta is 1/2 or cosine theta is 1. We'll have a principal value for each one of those. All right, so then for each principal value, we're going to have a separate general solution equation. So our first general solution equation will involve pi over 3, and because it's cosine, we're going to have pi over 3 plus 2 pi n, and negative pi over 3 plus 2 pi n. And that's from our cosine general solution equations. Now for the other equations, we're going to use our principal value of 0. So we'll have 0 plus 2 pi n, or negative 0 plus 2 pi n. But really, there isn't such a thing as negative 0, so we're just going to have the same exact equation. If it's exactly identical like this, 0 plus 2 pi n, you only have to write it once. If it's at all different, even if it's going to work out to the same particular solutions, you still have to rewrite it if it's different. Okay, so now we're going to find our particular solutions. We're still looking between 0 and 2 pi. So we'll start with an n value of 0 when we're just adding nothing each time. All right, and so then we know if we add 2 pi to pi over 3, that's positive. We're going to get something that's too big. But here with our negative value, that's where we want to add our 2 pi n. So go ahead and add negative pi over 3 and 2 pi n to get 5 pi over 3. And then finally, we've got 0 and we've got 2 pi n. So be careful, because a lot of times people will put both solutions, but take a look at the domain that we're looking for. We're including 0, but we're not including 2 pi. Okay, it's subtle, but you do need to pay attention to the details. So we have exactly 3 particular solutions that lie between 0 and 2 pi, and we'll rewrite those as our solution set. Okay, so now our next problem, we're using the same strategies, but this time we've got 2 theta and we've got theta, so our arguments don't match. We need to get the arguments to match first. So that's the first thing to do before we even worry about the fact that we've got cosine and we've got sine. So since we're looking at cosine 2 theta, let's use our double argument property to transform this side of our equation into something with just theta. And more than that, remember, we've got some choices when it comes to cosine and our double argument property. So let's use the one that uses just sine, because we've got sine over here. Okay, so now we've got sine on both sides, and we've got our argument matching. We're in good shape. So now it's time to solve. let's go ahead and isolate your trig function. But then we end up adding the 2 sine squared theta on both sides, and it goes away entirely. So then we have something like 1 equals 2, which we know is not true. If you come up with something that is not true like this, with 2 different constants, then that means that there are no solutions that will make this equation work. Okay, so we're going to continue on. We've got another problem where we need to worry about the argument. So we've got our double argument property that we can use for sine, and there's only one choice there. And I'm actually going to do this problem twice. I'm going to show you something, and so we're going to work through and we're going to do what most people would expect to do initially, and then we're going to solve it a different way, and we're going to see what happens. So we'll just get ready to solve it twice. So we're going to solve it over here and over here. Okay, so we've got 2 sine theta cosine theta equals cosine theta. And the knee-jerk reaction is divide both sides by cosine theta. Okay, and so if you do that, all right, our cosine thetas cancel on both sides. And we end up with, that's supposed to say sine. 2 sine theta is 1, so sine theta is 1/2. And so our principal value is pi over 6. But then there's another way to solve this. Okay, so instead of dividing cosine theta on both sides initially, let's subtract cosine theta from both sides. Okay, well now we've got cosine theta in both of these terms. Oh, hey, we can factor that cosine theta out. Okay, and then when we use our zero product property, we get cosine theta is 0 and sine theta is 1/2. Well, we have sine theta as 1/2 over here. We just didn't have the cosine theta equaling 0. So now we have 2 principal values, where over here we only had 1 principal value. So by canceling out our cosines, we canceled out all of these potential solutions. Okay, so it's super, super important. Do not divide to cancel. If you do, you end up canceling out not just a principal value. We'll see later on, we end up canceling out half of our general solution equations, half of our particular solutions. So it's very, very important. So that's why I wanted to show this problem 2 ways. Don't divide to cancel. Instead, add or subtract and factor. Okay, so we'll continue. We've got 2 general solution equations that we can come up with from our first principal value. Since it's cosine, we have PV plus 2 pi n and negative PV plus 2 pi n. Then we also have our 2 general solution equations from our sine principal value. So we've got our PV plus 2 pi n and then pi minus PV. So be really careful to not use your cosine equations. Okay, so then go ahead and find your particular solutions. Pause the video if you need to. All right, so now you can see that by adding and subtracting and factoring, we have these 2 additional particular solutions that we would not have had if we had canceled out. So be very, very careful. All right, so our next problem gives us kind of a twist on what we just looked at. So here we've got theta and theta, that's fine, and we've got cosine and sine. Since they don't match, we need to do something else to get this to work. Now, nothing's squared, we can't use the Pythagorean property, but we've got another property that relates cosine and sine. We've got the quotient property. So if we could have sine over cosine or cosine over sine, we could turn it into tangent or cotangent. So what we can do is we can subtract cosine theta from both sides in order to divide it. Now, I know what you're thinking. You're thinking, don't divide, don't divide, don't divide. We just did that. However, it's okay to divide as long as you're just dividing to rearrange. So I'm not crossing cosine off of both sides. It's not disappearing. It's just moving. So as long as you're just dividing to move it and you're not going to cancel it out, then it's okay. Because now what we have is we have tan theta is -1, which we can work with. We can get our principal value, we can get our general solution equations, and then we can find our particular solutions from there. Okay, so if you need a little time to wrap this problem up, go ahead and pause the video as necessary.